Next, networking fundamentals. Let's take a look. Networking fundamentals teaches the building blocks of modern network design. Here are the types of network. There are many types of computer networks. Common types of networks include the following. Local area network, LAN. The computers are geographically close together, that is, in the same building. Wide area network, WAN. The computers are farther apart and are connected by telephone lines or radio waves. Metropolitan area network, MAN. A data network designed for a town or a city. Home area network, HAN. A network contained within a user's home that connects a person's digital devices. Virtual Private Network, VPN. A network that is constructed by using public wires, usually the internet, to connect to a private network. Storage Area Network, SAN. A high-speed network of storage devices that also connects those storage devices with servers. Network models. Network models are used to define a set of network layers and how they interact. The two most widely recognized network models include OSI network model, TCP/IP model. Let's click each label to learn more. OSI network model. The Open System Interconnect (OSI) is an open standard for all communication systems. The OSI model defines a networking framework to implement protocols in 7 layers: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. Click each label to learn more. Physical layer. This layer conveys the bit stream, electrical impulse, light or radio signal through the network at the electrical and mechanical level. It provides the hardware means of sending and receiving data on a carrier, including defining cables, cards, and physical aspects. Examples include Ethernet, FDDI, B8ZS, V.35, V.24. Data link layer. At this layer, data packets are encoded and decoded into bits. It furnishes transmission protocol knowledge and management and handles errors in the physical layer, flow control, and frame synchronization. The data link layer is divided into 2 sub-layers: the Media Access Control (MAC) layer and the Logical Link Control (LLC) layer. Examples include PPP, FDDI, ATM, IEEE 802.5/802.2, IEEE 802.3/802.2, HDLC, frame relay. Network layer. This layer provides switching and routing technologies, creating logical paths known as virtual circuits for transmitting data from node to node. Routing and forwarding are functions of this layer, as well as addressing, internetworking, error handling, congestion control, and packet sequencing. Examples include AppleTalk DDP, IP, IPX. Transport layer. This layer provides transparent transfer of data between end systems or hosts and is responsible for end-to-end error recovery and flow control. It ensures complete data transfer. Examples include SPX, TCP, UDP. Session layer. This layer establishes, manages, and terminates connections between applications. The session layer sets up, coordinates, and terminates conversations, exchanges, and dialogues between the applications at each end. Examples include NFS, NetBIOS names, RPC, SQL. Presentation layer. This layer provides independence from differences in data representation, example encryption, by translating from application to network format and vice versa. This layer formats and encrypts data to be sent across a network, providing freedom from compatibility problems. Application layer. This layer supports application and end-user processes. Communication partners are identified, quality of service is identified, user authentication and privacy are considered, and any constraints on data syntax are identified. Everything at this layer is application specific. This layer provides application services for file transfers, email, and other network software services. TCP/IP model. The TCP/IP network model is a 4-layer reference model. All protocols that belong to the TCP/IP protocol suite are located in the top 3 layers of this model. Number 1, application. Number 2, transport. Number 3, internet. Let us look at each in detail. Number 1, application. Defines TCP/IP application protocols and how host programs interface with transport layer services to use the network. Protocol examples include HTTP, Telnet, FTP, TFTP, SNMP, DNS, SMTP. Number 2, transport. Provides communication session management between host computers. Defines the level of service and status of the connection used when transporting data. Protocol examples include TCP, UDP, RTP. Number 3, internet. Packages data into IP datagrams which contain source and destination address information that is used to forward the datagrams between hosts and across networks. Performs routing of IP datagrams. Protocol examples include IP, ICMP, ARP, RARP. Here's a question for you. Which of the following network is constructed by using public wires? Is it Metropolitan Area Network (MAN) or Local Area Network (LAN)? Is it Storage Area Network (SAN) or Virtual Private Network (VPN)?